I will find the area of a sector in a circle. So we can see this is a circle here, and these two are radius, two radius. Now because of these two radius, there is a sector here which is shaded by this one, and this is called the major sector. So it's the major sector because this is the bigger one, while there is the red one which I have enclosed it with the red, which is called the minor sector. And we can see that the two radius and this chord has formed a triangle. So we will try to find the area of the major sector first. So let's say this angle is theta. Now when we say the area of the full circle, so that is 2 pi. We can the area of the full circle is pi r square, sorry, and this angle is theta here. But when we say the area of the full circle, basically what happens is, if this angle, instead of becoming like that, if it were to rotate like the full circle, then we would get the full area of the circle. So basically if it had rotated for 2 pi, we would get the full circle, because then the sector would be the whole circle. So we know this is the area of the whole circle. We can write it like this: half 2 pi r square, and 2 pi is the angle through which it would rotate. So when it rotates for a smaller angle, which is this theta, the area would be half theta r square. So that's the area of the major segment, and the minor segment will be the major segment minus the area of the triangle. So this is the triangle here, which has, this is r here, this is r here, and this angle is theta. And we know that when we have the two arm length and the interior angle, we can write the area of the triangle as half r times r, because these two are the arms, times the sine of the interior angle. So basically half r square sine theta. So the area of the minor segment, which is the red one, will be this area subtracted by this area. So basically half r square theta minus half r square sine theta, which also can be written half r square theta minus sine theta. So this is the area of the minor segment, and we can make an interesting observation. When the theta is very small, so if we have a very small major segment, the minor segment, so when theta is very small, theta tends to 0, we know that sine theta becomes theta. So this one is equal to this one. So the area of the minor segment becomes 0, almost 0, when the theta is very small. While when it's major segment, when its theta is 2 pi, that's the full circle, basically there is no minor segment. The major segment becomes minor segment, because in this formula what happens, this is 2 pi, so we have half r square 2 pi, which is the full circle formula, which is so that becomes pi r square, which is the full circle formula, and also the major segment is that. But this one, in this formula, sine 2 pi is 0. So basically the major segment and minor segment both are the same. Basically that's what will happen, because it's the full circle. So for problems, what we need to remember is this formula, area of the major segment, and this formula, which is area of the minor segment. And we always have to remember that theta has to be in radian. If it is given in degree, it has to be converted in radian before we can apply this formula.